Okay, welcome to this fifth video on factorising. Now, we've looked at all the factorising methods. It's three different types, and we're going to apply them to algebraic fractions and how we can simplify algebraic fractions. Just, if you watched other videos, then you should know the order that we do factorising, or we check for factorising. And I've taken a wee note of the rules. Number one, you always check to see if you can take out a common factor in a question, and hopefully that helps you to simplify it, might be able to simplify the fraction. Once you've checked for a common factor, you then check for the difference of two squares. Now, difference of two squares, two terms, and we're talking about square terms. So the first term needs to be a square, and the second term has to be a square as well, and it has to be the difference. And that's very easy to factorise. You just write down the answer to that. So that's an easy one to factorise. And the last one, trinomials, well, that's a harder type. So when you've got three terms. So you must do your checks in this order. And depending on the question, you can get taking out a common factor, and then you can get a difference of two squares. Or you can take out a common factor and then it could be trinomials. Now, you know if you're going to have to factorise a trinomial because it'll have three terms. If it only has two terms, then you're either going to take out a common factor or the difference of two squares, or both. You might take out a common factor first and then the difference of two squares. Now I'm going to do a few examples here just to show you the things you have to be thinking about. Okay, so my first example, 16x plus 40 all over 8. Now, can we simplify that? And the answer is yes, we can, using these rules here. So we check through the rules. Well, right away, we're not doing a trinomial because we don't have three terms on the top there, so trinomial's out. So it's only between these two. Well, we can see it's not x squared. That's a square number, but that's not a square term. Therefore, the difference of two squares is out. So only the possible thing is if we take out a common factor. So here we go. Highest common factor between 16 and 40. Well, the answer to that is 8. If we take 8 out, it goes inside the bracket. That's going to be 2x plus 5. Now, how did I get that? Well, the top line, if you write that out in your grid format, your grid, highest common factor is 8, so take 8 out. 8 into, or 8 times something gives me 16x, so that must be 2x. 8 times something gives me 40, so it must be plus 5. So that's how we got our answer. Do you think you probably should be able to do that wee bit in your head to get there, but if you can't. So that's the top bit done. It's all over 8. Now, we can simplify that. Now I'm going to do a wee bit over here just to show you how things can simplify. Now, because it's products and quotients, or multiplication and division, if you like to prefer those terms, we can simplify that because we only have a product 8 times that bracket divided by 8. Because we only have those two operations, product, quotient, we can cancel out the 8 into 8 goes once, 8 into 8 goes once, so we've got 1 over 1, and the final answer is just 2x plus 5. Now, I'm just going to show you a common mistake that people make. Product and simplifying and quotients and addition, subtraction. If we had something like this, let's suppose instead of having what we've got there, we cannot just cancel them out to get 1. Okay, that's wrong. You can only do it when you've got products and quotients together. We don't have any addition. We have an addition sum here in the top, so we just can't cancel the 8 out. It doesn't work. And if you don't believe me, you can shove in numbers and you'll see that it doesn't work. Okay, so it's got to be products and quotients. So I'm just going to put that down here, product and quotients. So when we're simplifying these things, that's what we've got to have in mind. We can only do it when we have products and quotients only. Only put only in there. Okay, so let's look at a slightly harder example. Let's look at 7x plus 14 all over 63 minus 14y. So again, what we're looking at here, well, we go in this order, but again, just having a wee look at number 3, trinomials, 3 terms, right? Trinomial means 3 terms. I'll just stick that in there. We don't have 3 terms, it's 2 in the top, 2 in the bottom. So trinomials is out. So let's go to the top one. Take a common factor out. Well, look at the top. Well, the top, hopefully you can see we can take 7 out as a common factor. Hopefully that's obvious to you. All over, well, the bottom, we can take 7 out of there as well. And that's going to give me 9 minus 2y. Now do the grid method. If you're not happy just looking at that and seeing that comes out, then do the grid method and you'll see that's what you'll get. There's our products and quotients only. Product, product, and we're dividing, so that's a quotient. So that's all we've got. So the 7s can cancel out. 7 into 7, or 7 divided by 7 is 1. So our final answer, x plus 2 all over 9 minus 2y. Okay. Now, I would expect you to be able to do a common factor in your head. Difference of 2 squares, definitely in your head. Trinomials, we will have to put in the work for that. It's not easy to do in your head, the trinomials. Okay. Now let's pick another one to do. Let's look at this one. 10pq plus 25q all over 35p plus 10p squared. So looking at that one there. So again, we don't have a trinomial because we don't have 3 terms. So let's take out common factors. What do we know common factor wise? What do we know? Well, the top one. Well, 10 and 25, so we could certainly take a 5 out. And we've got a q here and we've got a q, so we could take a q out as well. So inside the bracket, we would need 2p, because 5q times 2p would give me 10pq. And the other part of it would be 5. 5q times 5 gives me 25q, and that's what we have on the top. So let's look at the bottom. Well, we can certainly take 5 out again, so let's take 5 out. And we can certainly take a p out as well. So 5p times something must give me 35p, well that would be 7. And 5p times something must give me 10p squared. Well, hopefully that's quite easy as well, 2p. Okay. So let's try to simplify that then. How do we get that simplified? Well, looking at that, we're going to get the 5s can cancel, so I've got a q here, 2p plus 5 over, I've got a p out here, and I've got 7 plus 2p. We can't cancel anything else there. I think that's it. Nothing else cancels there. So that's what we're left with. Okay, so not much cancels down there, but we can certainly get rid of the 5. Okay, right, let's try one that's a wee bit different. The ones we've not tried yet. Right, let's look at, say, c squared minus 49 over 2c minus 14. Okay, so hopefully it's obvious. Trinomials is out because we don't have three terms. First one, taking out a common factor. Well, we can't take a common factor out of the top one because it's not got anything in common there. We do have, it is common in the bottom. We do have something in common in the bottom, so let's just write that out then. So top bit doesn't have anything in common. Bottom bit does. You can take 2 out. So that's going to give me C minus 7. 2 times something gives me 2C, so that's C here, 2 C's. And a 14 there, so 2 times 7 must give me negative 14, so it's negative 7. So, common factor, we've done that. Next step, difference of 2 squares. Well, hopefully you can realise that this is a square term. Now 49 is a square number, so we can write that in terms of 7 squared. So the top bit, just by looking at it, goes to C plus 7, C minus 7, all over 2 C minus 7. We won't have products and quotients. That's all we've got. That times that divided by that times that. So times or products and quotients, so we can cancel down. So that will cancel with that and leaves us C plus 7 all over 2. Now, just a wee note. If we had this, now obviously we don't have this, but if we did have something like that, here, we can't cancel them down. Okay, a very common mistake they make at National 5 level, or pupils make, is they cancel that down when they can't cancel it down. Okay, so you need to be aware of that. Products and quotients. That's your mantra, if you like. Okay, let's do another one with difference of 2 squares in it. So let's see this one. I think this one's actually a past paper question. I think I've saw this in a past paper before this one. So I've got that all over 2m plus 6. Okay, so first thing, check for a common factor. Well, for the top, definitely a common factor. We can take 2 out. That leaves me m squared minus 9. Okay, 2 times something must give me 2m squared. So it's 2 times m squared. Got 18 here, I've got a 2. 2 times something must give me 18, so it's a 9, so it's minus 9 here. For the bottom, we can take a 2 out for the bottom as well, so take a 2 out, so that's going to give me m plus 3. So you can cancel the two 2's just now because quotients, products and quotients. So we could do that. I think I'll just cancel them down just now. 2 divided by 2 is 1. So that gives me m squared minus 9 over m plus 3. Now most people, again, some people at National 5, they'll stop there and they only get a mark for that. But you should be checking for the difference of 2 squares. Difference of 2 squares, so the top one, without any working, you just write down as m minus 3 and m plus 3. And that's all over m plus 3. Products, quotients. Products, quotients. So that can cancel with that to give me 1, because m plus 3 divided by m plus 3 is 1. And your final answer is m minus 3. I tend to put a wee bracket in. You don't need the bracket, but I tend to keep that in. Okay. So again, that's the difference of 2 squares and the common factor. Very common to come up in the exam. I would bank on that coming up in the exam. So let's try some ones that are a wee bit more difficult. So let's see, what will we do? What about a squared minus 1 over a squared plus 2a plus 1? Okay, so we get that in the exam, so how do we go about that? Well, first thing to note, under no circumstances can you just cancel them out, okay? Because it's a subtraction sum at the top, okay? It's not multiplication, it's subtraction. and this is all subtraction here. So we have to change it into products and quotients, and then if we only have them, then we can cancel down. Well, hopefully the top one's dead easy. It's a difference of two squares. 1 is a square number, so we can write that as a minus 1 times a plus 1. Now the bottom one, now it's trinomial, so we really do have to do the grid method for that, to be honest. So let's work it out. First term, top left, bottom term, bottom right. And we need two numbers that are going to multiply to give me AC. Now AC is 1 times 1, so that's going to give me 1, must give me 1. And at the same time, they must add, the same numbers must add to give me the middle term, which is 2, and it's a positive 2. Okay, so factors of 1, well, the factors of 1 is just 1. So 1 times 1 gives me 1, that works. Or 1 plus 1 gives me 2. So it's 1 and 1. But remember, because the middle term's got an A in it, it's actually A plus A that we need to give us 2A. It's not just the numbers there, we need the A's involved. So where do we put them? Just, well, 1 there, it's the same thing. And that's a positive 1 and that's a positive A, just make sure we're clear. So the top bit, what we've got in common? A, so we can take it out as common. A times A gives me A squared, so that's an A here. A times something must give me A, so that's going to be a plus 1, so that's going to be 1 in my brackets. In my other bracket here, we only have 1 in common, so it's a positive 1 we take out. That's my other bracket, so I've got two brackets that's actually the same. So I have A plus 1, A plus 1, products and quotients, so we can cancel out, so that divides that, gives me 1, and we're left with A minus 1 over A plus 1. Final answer, we can't cancel down. Don't be tempted to cancel them out, can't do that, okay, because that's a subtraction, add. Yeah, that's your final answer there. I think I'll do one more and then we'll just leave it at that. We've done a few examples there. Let's say that one there we just did, again, does come up in the exam, so make sure you can do it. I wouldn't leave this, especially if you're going to do higher. Want to do higher, you have to be very good at this type of stuff, okay, algebraic fractions, and being able to simplify them. So here we go here, we've got that there. Now first thing we take for a common factor on the top, no, don't see any common there, apart from 1, so we can't take anything out there. Any common in the bottom? No, I don't have anything common apart from 1. Difference of two squares, well, can't be because there's 3 terms. So we've actually got 2 trinomials that we have to factorise, and hopefully they'll cancel down. So I'll do the first one up here. 2x squared plus 13x plus 6. So we need 2 numbers that are going to multiply to give me AC. AC being 2 times 6, which is 12. And at the same time, the same 2 numbers must add to give me the middle term, which is 13. Well, factors of 12, 1 and 12. Oh, 1 and 12. Well, 12 plus 1 is 13. So there you go, very quickly. 1 and 12. 1 plus 12, 13. So remember, it's really x plus 12x is equal to 13x. So let's work that out then. So get my grid. We need 2x squared in here, we need a 6 here, and where does the x and the 12 go? Well, again, it doesn't matter, I can put it anywhere I like. I think I'll put the 12x here, and remember that's a plus 6, and we'll put a plus x here. So what's the factors going to be then? Well, for the top bit we can take x out, and for the bottom bit here we can take 6 out, I think. Yeah, 6 can come out. So let's let's see if we're right with that. So x times something must give me 2x squared, so that's going to be 2x. X times something must give me x, so that's going to be a plus 1. So that's going to be one of my brackets. And this must be my bracket here. Okay, so I've got my top bit sorted out. That's going to be 2x plus 1 and x plus 6. Now I have to do the bottom one now. So doing the bottom one, so we have to do the same idea again. So need two numbers that are going to multiply to give me AC, so that's 1 times 18. So I need two numbers that are going to multiply to give me 18. And at the same time they need to add to give me 9. So factors of 18, well 1 and 18, that's not going to help me I don't think. 2 and 9, that's not going to help me really, because when I add them I get 11. 3 and 6, oh 3 and 6 is going to work, isn't it? 3 times 6 is 18, so let's just put it in. 3 times 6 is 18, and 3 plus 6 is 9, so that's going to work. So that'll be 3x plus 6x equals 9x. So get my grid sorted. First term top left, last term bottom right. 3x and 6x, well we'll put them, I think I'll put 6x here, and we'll put the 3x here. So common factor here x, common factor here 6, and it's a positive 6, so that's going to be a bracket. X times something gives me x squared, so that's going to be an x. X times something must give me 3x, so that must be plus 3 then, that's my second bracket. Okay, so on the bottom I'm going to have x plus 3, x plus 6. We can now cancel down because we have products and quotients only. So that means x plus 6 divided by x plus 6 gives me 1, so they cancel out, and I'm left with 2x plus 1 all over x plus 3. Finished. Done. Okay, so I think I've done enough of them. That should help you to do algebraic fractions, simplifying algebraic fractions using factorisation. Comes up a lot at National 5, so you need to know it, practice it a lot. Go to mathsrevision.com if you want extra practice, and if you're going to do higher you have to be good at that. So if you want to be doing higher after National 5, you need to be good at this to get higher. Okay.